Hello all. Are you able to hear me? Can you all please confirm? Friends, are you able to hear me? Perfect, perfect. A lot of you all are able to hear me. So that means there is no issue at my end. And that means we should get started. We will be reaching 1,000 people shortly. Oh, it's 1,021. Good. That's a good number. Out of 4,100 people who have registered. Okay. Let us continue with the session. Is this session being recorded? You might want to confirm over WhatsApp to me. Okay, we'll wait for just 2 more minutes, friends. We are expecting a few more people to join. So 2 minutes and then we will get started. People who claim that they are unable to see my screen, I would open the Ultimate Pen and write it here. We will start in the next 1 minute. Okay, so one more minute and then we'll get started. Because there is a lucky draw, we want to inform on who has won the lucky draw. Okay, so we are waiting for a few more people to join in. Okay, 1 more minute and we will get started. Okay, I think we should get started now. So yesterday, when we looked at the number of people who have attended, we had participants from 1, 2, 3. I mean, it's starting from serial number 2 here until 1555. Okay, these many people were there for minimum 1 hour 30 minutes. That's the cutoff which we have taken. From today onwards, we will look at 1 hour 45 minutes as a cutoff. That means you should attend the entire session. As promised yesterday, we will do the lucky draw, and I'm making use of random number generator, which would randomly generate the number in the range of 2 to 1555. Why? Why did I choose 2 as a minimum number? Because you have from row number 2, so 2, 3, 4, 5 until 1555. So I've taken those numbers 2 until 1555, and now I am going to randomly generate a number. So let me show you a few things, right? When I click here, it randomly generates some number in that way. It randomly chooses a number, okay? So I'm not doing it. Google is doing it. So don't assume that we are manipulating things here. No, everything is very clear, very open. And whosoever number comes here, they will win a surprise gift from our side. Okay, they will get an Amazon coupon, but how much, etc., you will get to know. That's a surprise. So let's get started. Let us see who is that person who is going to win this. But let me see how many people are there. We have 1,331 people. I have my fingers crossed. Who will win? Let's see. Let me click on generate now and see who is that lucky winner. Okay, it's 1477. Sai Teja. Sai Teja, I have hidden the email IDs. I have hidden the email IDs. You would receive an email from our side. Okay, 1477. I'm double checking. Yep. Sai Teja. You would receive an email from our side with the coupon. Congratulations. Are you there in the session? Let me see. Are you there? Sai Teja, can you identify yourself? Okay. So let me do this. If Sai Teja is not available, is he there? Not sure. Yeah, you're there. Okay, good. Congrats. All right. So people who stay until the end, you don't just learn the amazing concepts of data science for free, but you also get to win such prizes. Okay. Second, if you attend all the classes, you would also get a certificate from our side. We don't give certificates to everyone. We don't do that. Only for people who stay until the fag end. Last day, last minute, you would get that. Another thing is, a lot of people were asking me on, hey, can you share yesterday's recorded video? Yeah, we have it. Okay, and one more thing, please subscribe to our YouTube channel. We will look at whether you have subscribed or not. Tomorrow we will check that. So please subscribe. And I'm going to place this and share with everyone. Okay, so people who are saying that you haven't received any link, here you go. I've pasted the link of the YouTube channel. Please subscribe. Only then you would be able to see the future videos. So please subscribe. Yep, click on this button there and click on subscribe. The third thing, and the most important thing is, there will be an attendance tracker which we are going to publish at the end of the training. You'll have to click on that and give your attendance. Okay, so please subscribe to our YouTube channel, number one, so that you do not miss out on the videos. I shared the link in the group. Please make use of that link. If you want, I can also share it once again. I've done that once again. Okay, next. Yep, from today onwards, if you stay until the end, okay, you will receive the certificate. That's okay if you missed yesterday, but henceforth you should be there. All right, thank you all so much. Let us continue. Yesterday we discussed about data science. Okay, and we started off by discussing about what are the various data types. And then we discussed that data, if represented in decimal format, if it makes sense, that's continuous data. And if you have data which, if you represent in decimal format, and if it does not make sense, it is discrete data. Then we discussed about nominal data, ordinal, interval, and ratio. We discussed about these. If a few of you all do not remember, then watch my recorded video and you will understand these. Let us get started today with the remaining concepts. Okay. All right. We discussed all these data types. Today we're going to discuss about probability. The moment we say probability, majority of the people switch off. Switch off in the sense they switch off their brain. Oh my God, probability, not again. Yeah. Do not worry, friends. We all are the birds of the same feather. So I'm going to help you understand probability, and we will make it extremely simple. Okay, we'll make it very, very easy for you to understand. Formula of probability is number of interested events divided by total number of events. Simple, very simple. To understand this, let us say you toss a coin. Let us say you toss a coin. When you toss a coin, you might either get a head or you might get a tail. Let us look at what is the probability that you would get a head when you toss a coin. You're interested in an event called head, and head is an interested event, right? That is the event that you are interested in, and head is a single event. That's one head. So one event divided by total number of events. In total, how many events do you have? 2 events. In total, how many events do we have? 2 events. So you divide it by 2, job done. If you want to look at probability of tail, okay, tail is a single event. So the number of interested events is only 1, tail, divided by total number of events. In total, you have 2 events, head and a tail. So you divide it by 2. If you roll a die, what would you get? You might get a 1 or 2 or 3 or 4 or 5 or 6, right? If you roll a die, you would get one of these numbers. What is the probability of getting a number 1? Probability of getting a number 1 is Number of interested events, numerator, is 1. You're interested in a single number called 1, divided by, what are the total number of events that we have here? 1, 2, 3, 4, 5, and 6. 1 by 6. What is the probability of getting a 2 here? Again, you are interested in a single event called 2, which is a single number. So number of interested events is 1 divided by total number of events are 6. So 1 by 6. Right? So in short, for 3 also it is 1 by 6. For 4 also it is 1 by 6. For 5 also it is 1 by 6. And for 6 also it is 1 by 6. Simple. Very easy. Now, question to you all. Suppose you roll a single die. Of course, die is singular any which ways. What is the probability that the outcome will be bigger than 3? What is the probability that you will get a number which is bigger than 3? Hint. What are the total possibilities? You can get a 1 or 2 or 3 or 4 or 5 or a 6. And what is the probability formula? Number of interested events divided by total number of events. All right. So I want to know this, that if I roll a die, what is the probability that the outcome will be bigger than 3? Yep. I'm interested in event. The interested event numerator is bigger than 3. Anyone? Please, I request everyone to resort to chat window and give a response. Please, can you all reply? Friends, can you all please reply? Okay. Wonderful. Wonderful. A lot of you all are getting it right. Amazing. Amazing. So let me go here. Yes, you all are right. So when you roll a die, you want to know on what is the probability that the outcome would be bigger than 3. Bigger than 3 are only 3 numbers. Bigger than 3 are 4, 5, and 6. So these are 3 numbers out of total events. In total, how many numbers do we have? 6 numbers. So it's 3 by 6, which is nothing but 1 by 2. Now let's look at the second one. If you roll a single die, what is the probability that the outcome would be equal to or bigger than 3? What would that be? Come on, please respond. I request everyone to please resort to the chat window and respond with your responses. Equal to or bigger than 3. So that means you are interested in an event which is greater than or equal to 3. Means you want to know whether the event would be 3, equal to 3, or bigger than 3. Bigger than 3 are 4, 5, and 6. So you have 4, 1, 2, 3, 4 interested events. And what are the total events possible? 1, 2, 3, 4, 5, 6, which is 2 by 3. Perfect. Wonderful, friends. A lot of y'all are very actively participating. I really appreciate that. That is needed, right? To motivate the other people also. Okay, let's move on to the third point here. And the third point, or the third question here is, what is the probability that if you roll a die, you get a number which is smaller than 4, less than 4? Hey, sorry, friends. I think there was a glitch. My bad. Until where did you listen to my session? Where did it break? Are you all able to hear me now? Are you all able to hear me now? Okay. Not sure what went wrong. Okay. Until where did we discuss, friends? Probability. So let me explain once again. So suppose you roll a die. What is the probability that the outcome is bigger than 3? Did we discuss this? Were you able to hear? Please, can you confirm? Yes, sir, or no? Third question. Okay. So did you hear the third question, or is it at the fourth question that you weren't able to hear? All right, got it. So let's crack this last one. So what is the probability that if you roll a die, you'd get a number which is bigger than 2 and less than 6? If you roll a die, what are the possible outcomes? You might get a 1 or 2 or 3 or a 4 or a 5 or a 6. Okay. And probability formula is number of interested events divided by total events. Now, greater than 2 and less than 6 are these three numbers, 3, 4, and 5. We have three numbers. 3 are the interested events, divided by 6 is the total count, and then you get 1 by 2. Clear until here? And then what I have done is I've opened the mind map, and then I've written down the formula for probability, which is number of interested events divided by total number of events. All with me, so I'll be frequently checking my chat window henceforth so that there is no confusion. All with me? Shall we move to the next step? Perfect. All right, let us move on and now understand about probability distribution. Very important concept, friends. Very important concept. So here you have a table and you have the details on how many iPads you sold every day. On day 1, you sold 0 iPads. On day 2, you sold 4 iPads, Apple iPad. Day 3, you sold 2 Apple iPads. On day 4, you have sold 3 Apple iPads. On day 5, 1 Apple iPad, so on and so forth. Now, if you want to look at, say you want to convert this table into a probability distribution table. That means you look at how many iPads you are selling on a daily basis. And you also did not sell any iPad on one of the days, right? 0. So if you want to look at probability of selling 0 iPads, what is the formula for probability? Again, the same thing. Number of interested events divided by total number of events. Say you have this data for 30 days. You have the sale of Apple iPad for 30 days. What is the probability of selling 0 television sets? So it's total 30. So total events, that is the denominator, is 30. And numerator, how many values do you have? Number of interested events. 1, 2, 3, 4, somewhere on 12th day, say you did not sell any, so on and so forth. If you have all these numbers and if you count these numbers, say you found that you sold 0 television sets on 12 days out of 30 days. What is 12 by 30 equivalent to? It is equivalent to 0.4. And that is what is listed down here. What is the probability of selling 0 television sets? It's 0.4. We have it. In that way, you also look at how many times you sold 1 television set. Probability associated with that is 0.25. Now let us look at how many we have sold, what is the probability that you have sold 2 television sets. Let's see. Let's get that number also. So you have 2 here, 1, 2. In that way, many times, right? So probability of 2 is equal to total number of events are 30. Total number of events sold are 30. Out of that, how many times do you see number 2? 2 Apple iPads getting sold. 1, 2, 3. In that way, if you count, say you have 6 days. 6 days out of 30 days, you sold 2 Apple iPads. So when you solve this, you get 0.2. So probability of selling 2 television sets is 0.2. In that way, say you have data of probability of selling 3 Apple iPads and 4 Apple iPads. So you have this data. What is this demonstrating? This is demonstrating the distribution of the probabilities. Probability values are distributed. Hence, this is called as probability distribution. Now, question. I request everyone to stay focused. You will have to answer these questions now. Okay? And the question to you all is this probability distribution pertaining to sale of Apple iPad called as continuous probability distribution, or is this called as discrete probability distribution? Anyone? What is this called as? Continuous or discrete? Come on, friends, please respond. I have sale of Apple iPad. Is it continuous or discrete? Okay, there are mixed responses. Oh, I see. There are mixed responses. Next time I'll do a poll to understand how many of y'all are getting it right. Okay, so these are all count, right? So can I say I have sold 1.7 Apple iPads? Can I say that? Can I represent in decimal format the number of iPads sold? You cannot. You cannot represent, because it does not make sense. Either you sell 1 iPad or 2 or 3 or 4, right? But you cannot sell 1.7 iPads. If you cannot represent a number in a decimal format, the underlying data is called as discrete data, and the associated probability is called as discrete probability distribution. It's called as discrete probability distribution. Instead of the sale of Apple iPad, the count, if I give you the numbers in dollars, say you made sales worth $1,000, you made sales worth $4,040, so on and so forth. Instead of the count of Apple iPad sold, if I give you the dollars, then would it be called as continuous probability distribution, or would it be called as discrete probability distribution? Yep. What do you think, friends? Let me see your responses. Exactly. Now you all are getting it right. You all are getting it right. Perfect. So because amount can be represented in decimal format also, you can say .50. $1,000, 50 cents, it still makes sense despite representing this in decimal format. Any number, if it is represented in decimal format and if it makes sense, that is called as continuous data, and the corresponding probability distribution is called as continuous probability distribution. Wonderful. Now, say on x-axis, you plotted the number of Apple iPads sold. 0, 1, 2, 3, 4 iPads being sold. And on the y-axis, you say you're plotting probability values. Such a representation is called as probability distribution plot. This is a plot, a visualization. Probability distribution plot. Okay, so what is the probability of selling 0 television sets? 0, it's 0.4. So against 0.4, you have a bar. What is the probability of selling 1 television set? You have a bar at 0.25. What is the probability of selling 2 television sets? It's 0.2. So against 0.2, you have a bar. What is the probability of selling 3 television sets? It's 0.05, so you have a bar there. What is the probability of selling 4 television sets? It's 0.1. So you have a bar there. Okay, so you just put a bar. That's called as probability distribution plot. All with me? So let us record this and then move on. What will you have on x-axis? On x-axis, we will have, say, the variable, which is sale of Apple iPad or whatever be the value. And on y-axis, you will have probability numbers. And if this variable here is continuous, then the corresponding probability distribution would be called as continuous probability distribution. If the variable is discrete, you call the corresponding distribution as discrete probability distribution. Hey, what happened? Sorry, my bad. Right, this is how. I don't want to save it now. I'll save it towards the fag end. Okay. So this is probability and probability distribution. Now let's move on and learn about the next concept. So these concepts that you have learned are really, really amazing concepts, friends. Trust me on that. So if you were to look at the pointer and click on this, it would show me an article wherein Angelina Jolie, okay, actress, she has undergone double mastectomy. Right? Mastectomy means removal of the organ. Mastectomy means removal of the organ. And she has undergone double breast mastectomy, means removal of her organs, both the breast, because doctors have predicted that there is 87% risk of she having a breast cancer. Based on the probability values, she was the first celebrity to take an action. That's the power of probability. And I'll show you yet another application of probability in the space of judiciary. What has happened is a few years back, okay, it's all about application of probabilities, friends. So a few years back, there was a person by name Lucia Debug. She was a Dutch nurse. Under her supervision, a few babies died. And then immediately there was a lot of disappointment, and judiciary has imprisoned her and sentenced to life. They have sentenced her to life. Then came this statistician who has done some analytics, and he told, hey, there is one out of 342 million chances that she has committed the murder. And because of this statistician, because of the probability values, the court has convicted her. Sorry, acquitted her, my bad. And she was actually released scot-free from the prison 6 years after she was imprisoned. That is the power of probability. That is the power of probability. Okay? So these are not by any means ordinary concepts that you're learning. You are learning extraordinary concepts. Okay, next. Let us understand about another concept. See, all these concepts will help you build prediction models, right? So today and day after, we are going to set our base. And then we will start building our machine learning algorithms. So these are very important. Please pay attention. We will now discuss about something called as inferential statistics. We will learn about something called as inferential statistics. Say, Apple CEO walks up to you and says, hey, can you check with all the iPhone users on whether they're happy with the recent release or not? Say there is a version called XR. Are the Apple iPhone users happy with iPhone XR? And how many customers would Apple have? Say they have 2 million customers, just as an example. Say there are 2 million iPhone customers. Now, would you go and check with each and every iPhone XR user on whether they are happy or not? Would you do that, friends? Will you go and check with each and every iPhone XR user, all these 2 million people, to determine whether they are happy or unhappy? Would you do that? No. Would you have the time and energy to do that? No. A big no. Yes. So what you have to do as a data analyst or a data scientist, what you have to do is you have to come up with a sampling frame. What do you mean by a sampling frame? You probably say that, do you know what? 80% of iPhone users are in US. Maybe. So you will say that rather than going after the entire world to get hold of 2 million people, you would get hold of only 80% of people. That's your sampling frame. USA is your sampling frame. And on this sampling frame, you apply a technique called as SRS. SRS stands for simple random sampling. And this simple random sampling is also called as blindfolded technique. Why is it called as blindfolded? Because you just close your eyes and pick up a few people. That's why it's called as blindfolded. Simple random sampling. Just close your eyes, randomly choose a few people out of this USA, which is your sampling frame. Maybe you randomly choose 10% of the people. Okay, maybe you choose 10% of the people here, and then you interview them on whether they are happy or not. Though you are working on 10%, or though you are interviewing only 10% of the people, when you go back and explain to your Apple CEO, you make statements about entire population. If these 10% of people say that they are extremely happy, they say that we are extremely happy, then what would you communicate to Apple CEO? You'll just make a statement that iPhone XR users are extremely happy. Okay, you will never say that you have worked on a sample, right? Based on the sample, people are happy, so you're assuming that these people will be happy. You'll not make any such statements. You directly draw inferences from the sample and make statements about population. Since you're drawing inferences from this sample and making statements about population, the underlying statistics is called as inferential statistics. What is inferential statistics? You randomly choose a sample using simple random sampling technique and make statements about population. That is called as inferential statistics. And the next thing is, if you calculate mean or median or any measure on a sample, those are called as sample statistics. If you calculate some measure such as average or mean, etc., for the entire population, then those are called as population parameters. So if I go here, if you calculate mean or median or mode for population, entire population, then it is called as population parameters. If you calculate mean or median or mode for your sample, it is called as sample statistics. Okay, now we will try to understand more, but recap is important. What is inferential statistics, friends? You will have population, but you cannot go after your entire population. It is very costly. So what do? We craft a sampling frame. Maybe you might say, hey, 80% of the people stay in US. 80% of iPhone customers stay in US. So probably United States is your sampling frame. Then you apply a technique called as SRS and come up with a sample. SRS means randomly choose people. This is called as simple random sampling, and this is blind folder technique. That means you just close your eyes, pick a sample from your sampling frame. While you work on your sample, you make statements about your population, and this is called as inferential statistics. Okay, and when you calculate mean, median, mode, etc. for population, it is called as population parameters. When you calculate mean, median, mode for sample, it is called as sample statistics. Okay, so we have successfully completed this. So let me put the 20 hours program. Inferential statistics. Done. Now let us move on to the next step and calculate measures of central tendency, or this is also called as first moment business decision. What is this called as? This is called as first moment business decision or measures of central tendency. You have to do all of these analysis and document in a Word document and then share it with your customer friends. We are not learning these for fun. So you have mean, median, mode. Let us understand all of these three with an example here. Say you are CEO of HSBC Bank, and say you have your branches in India, in Singapore, and in UK. As CEO of HSBC, the first question, why is it called as first moment business decision? I'm answering that. As a CEO of HSBC, the first question that you would ask is, on an average, what are our sales across these locations? On an average, what are our profits across these locations? On an average, how many people do we employ across these locations? On an average, what is the attrition rate across these locations? These are a few questions that you ask. Okay, and these are the first set of questions that any senior management person would ask, and hence we have given that the name first moment business decision. Now let us calculate. Okay, let me take numbers 1, 2, 3, 4, and 5. How do you calculate the mean or average of these numbers? Anyone? What is the average of these numbers? Yep. Can you quickly respond? Let me see your chat messages while you do that. Come on, friends. Can you please respond? Yes. Average of these numbers, how do you calculate? You add all these 5 numbers, 1 plus 2 plus 3 plus 4 plus 5, add all these numbers and divide it by the total count. Total count is 5. So if you add all these numbers and divide it by 5, you get 3. This is mean. But the drawback with respect to mean is, say you take another set of numbers, 1, 2, 3, 4. So I'm ensuring that these 4 numbers are the same, and I'm going to change only one number. I'm going to replace 5 with 700. If I replace 5 with 700, what is the average going to be now? Average of all these numbers is, count all these numbers, you would get 710. 710 divided by 5 would give you 142. So the mean has significantly changed just because of this one number, 700. And these kind of numbers, which are extremely different, are called as outliers. Okay, these kind of numbers which are extremely different are called as outliers or extreme values. Okay, and what does this mean? This means that mean gets influenced by outliers. Instead of 3, because of this outlier, your mean became 142. So mean, the disadvantage is that when you have outliers, don't go with average or mean as a measure. So this gets influenced by outliers. Since this gets influenced by outliers, you need a different measure. What is the different measure going to be? Let's see. Which is not going to be influenced by outliers. That's called as median. Median is the middle value of a data set. Now look at this and tell me, what is the middle value of this data set? What is the middle number here? People? Yes, the middle number here is 3. So that's the median. And what is the middle number of this data set? What is the middle number of this data set going to be? Once again, 3. Wonderful. That means this median is not getting influenced by the outlier. That's a good thing. So when you have outliers in your data, you have to use median as a measure. So median is the middle value of data set. And advantage is that it does not get influenced by outliers. It does not get influenced by outliers. Okay, that's a good part. Now, what is mode? Okay, we also have to discuss about that on what is mode. We use mode when you have your underlying data, which is not continuous. So let me ask this example, or let me give this example. Do you all agree with me that married people, how many of you all are married? How many of you all are married, friends? Whoever is attending the class. Anyone? No? None of you all are married? Strange. Yeah, a few of you all are married, right? And people who are married will agree with me when I say that husbands are scared of wife. You all will agree, right? Husbands are scared of wife. So say some psychology department started doing a survey on how many people husbands are happy. And they ask, say, first person says, yeah, I'm really happy. Why did he say happy? Because his wife was watching him. Okay, then the other person, wife wasn't watching him. He says, no, I'm really unhappy. Then the third person also says, I'm unhappy. The fourth person is so scared that even when his wife wasn't there, he says neutral. I'm neither happy nor unhappy. And the fifth person also says, yeah, I'm unhappy about my marriage. Now, if you have the survey responses of these 5 people, what is the mean of this data set going to be? What will be the mean of this data set? What is the mean of this data set going to be? Mean, average, what will that be, friends? No, you cannot calculate mean. You cannot calculate mean. How about median? How about median? Can you calculate median for this? No, you cannot calculate median also. So mean and median cannot be calculated. So what do we do then? We resort to another technique which is called as mode. Mode is the most occurring value in the data. Among all of these, which value is getting repeated maximum times? Unhappy. Unhappy is getting repeated 3 times, maximum times. So the mode of this data set would be unhappy. Poor husbands, yeah, unhappy. So this is mode basically, right? Now I have a riddle for you all. Let us see who will get it right. 2 friends, Mr. Say Sai and say Mr. Teja, because Sai Teja won, right? I'm just giving this example. Okay, say Mr. Sai and Mr. Teja went to forest and they wanted to hunt a lion. Okay, or say they wanted to hunt some animal and they came across lion. Both of them were scared. This person released the arrow. He wanted to kill the lion, but this arrow missed the lion just by a whisker from the left side. And this Mr. Teja also tried his luck. He thought, okay, you could not kill, let me kill. And he releases the arrow and the arrow misses the lion from the right side just by a whisker. And both of them jump with joy. Okay, they are so happy. They jump with joy, they are happy, they hug each other. Why did they do that? Yep, riddle. Let us see who will answer this. Hope you got me. Mr. Sai and Mr. Teja went to jungle for hunting and they come across lion. Now either they kill lion or lion would kill them. So what Mr. Sai has done is he has aimed at the lion, he shot the arrow, but the arrow missed the lion from the left side. And this Mr. Teja also released an arrow and it missed the lion from the right side. But both of them started jumping with joy. They were so happy. Why were they happy? Because my friend failed, I also failed. Yeah. Yeah, that's human psychology. If both of you fail, you're happy. Exactly. A few of y'all are getting it right. A few of y'all are getting it right. So let's see. So the riddle here is that say you have one person whose weight is 40 kgs. I'm speaking about people whose age is 30 years. Two people whose age is 30 years. One person's age is 40 kgs. Is this overweight or underweight? For people who are above 30 years, is 40 kgs overweight or underweight? Is 40 kgs overweight or underweight, friends? Come on. It's underweight. Absolutely. And say there is another person. This is the weight of husband. During COVID-19, only husbands are working, it seems. So they obviously will reduce the weight, right? And say there was another person whose weight was 120 kgs. Yeah, and you all guessed it right. I can guess your brain actually, right? This is weight of wife. Because during COVID-19 lockdown, she doesn't work. She'll make husband work. So husband's weight dropped, wife's weight increased. Yeah. Okay. Then when you take an average of these two, what will the average? What will be the average weight, friends? One person is underweight, another person is overweight. On an average, which is 80 kgs, if you take average, on an average, their weight is okay. It's a normal weight. Right? And they both jump with joy saying that, yes, both of our weights are the same. Underweight, overweight, but on an average, we are normal. The same thing happened with Mr. Sai and Mr. Teja. One person missed from left, one person missed from right, but it's like 40 kgs and 120 kgs. When they have taken an average, they felt that these both were statisticians, by the way. Hence, they both felt that on an average, we killed the lion. And they keep jumping with joy, hugging each other while lion attacks them and kills them. Yeah. So being statistician and applying statistics everywhere could be life-threatening. Okay, be careful. Are you all clear with this? Okay. So let us take a break for quick 5 minutes. It's 3:03 now. So let me erase everything. And let me choose a pointer here, a different color. So I'll write it here, break time until what time? Until 3:10. Let us come back at 3:10 and let us continue. Okay, I'll be on mute until then. All right, perfect. Let us continue. So what did we discuss, friends? In the morning session, we discussed about probability, which is number of interested events divided by total number of events. Then we discussed about probability distribution. On x-axis, you'll have the variable, and on y-axis, you'll have the probability values. If the variable is continuous, it's continuous probability distribution. If the variable is discrete, it is discrete probability distribution. Then we have also started off by discussing about exploratory data analysis. And the first thing is first moment business decision, which is also called as measures of central tendency. In this, we discussed about mean, median, and mode. Mean gets influenced by outliers. Median is the middlemost value of data set. It does not get influenced by outliers. And then you have mode. Mode is used when we have categorical data. When you have continuous data or count data, for count data also you can use this, but when you have continuous data, you can use mean, right, or median. You cannot use mode when you have continuous data. Okay, we are done with this. Next, we have the second moment business decision. Here. Sorry. Next is the second moment business decision. And the second moment business decision is called as measures of dispersion. Measures of dispersion. There are three measures of dispersion: variance, standard deviation, and range. We will discuss about these three by taking an example. The same example, we'll just extend that. Say you are CEO of HSBC and you have your bank branches in India, Singapore, Singapore, and say UK. Say you have your branches in these three locations: in India, Singapore, and UK. Okay, all with me? Oh, is there an issue? Let me check. 1 second, I'm just checking that. Okay, all right. Say you have 6 months sales of India, and say you have 6 months sales of UK. When you have the sales for the next 6 months, or for the last 6 months rather, you take an average of that and say average sales is represented using the line here. And you have another line here. This also represents the average. Okay. Dispersion means what is the variation in your monthly sales? The first moment business decision, or the first question which your CEO would ask is, on an average, what are our sales? On an average, what are our profits? On an average, how many people are working, so on and so forth. And the very next question which you as a CEO would ask is, are the sales across these three locations the same, or are the sales varying? Right? Are the sales across these locations the same, or are the sales varying? Now say the first month sales in India was, let me choose a different color. just that you might get bored with this color. Okay, say it was so much. Second month the sales was close to average. Third month it was below average. Fourth month again it was above average. And then you have fifth month and then sixth month, so on and so forth. What do you mean by dispersion? How far away is each point from the average? How far away is each point from average? How far away is each month sales in comparison to average? Right? In comparison to average, how is your monthly sales varying? You have that. And I'll choose a different color. Which one should I choose? Let me choose yellow color. Okay, for UK. Say the first month sales in UK was outstanding. It's not visible, right? Let me choose a different color. 1 second. Let me choose sign. Okay, it was outstanding. The first month sales. It was above your average. Second month sales was much less than the average. Third month was somewhere close to average. Fourth month again it was exceptional. Fifth month again it came down. Sixth month it was here. So what do you mean by dispersion? How far away is each value, each month sales from average? How far away is each month sales from average? How far is each month sales from average? How far away is each month sales from average? Yeah, in this way. If you look at this, there is huge dispersion, huge variation. On the contrary, if you look at sales in India, the fluctuation or the variation is fairly less. It's less. Now you tell me, will you be more comfortable in predicting the sales for the next month for Indian market, or would you be comfortable in forecasting or predicting the sales for next month for UK market? Where would you be more comfortable, friends? Yep, let's see. Who is going to get it right? Would you be more comfortable predicting the next month sales for India, or would you be more comfortable predicting the next month sales for UK? Where would you be more comfortable? India or UK? India, everyone is saying India, right? Why do you think India? Because the uncertainty in the data is less, right? The uncertainty in the data is limited. There's only so much uncertainty. So you would be able to better predict the sales for the next month. You'll be able to predict with confidence. But here, there is huge fluctuation, huge fluctuation. It can be this high or it can be this low. Since there is that huge fluctuation, though you might predict the sales for the next month, it would not be accurate. This is called as dispersion. Hence, measuring dispersion is very, very important. Okay. Now, I'll give you, this concept is applied in a lot of amazing scenarios. Let me ask you this question on, how many of y'all are aware of US Food and Drug Administration? How many of y'all are aware of US Food and Drug Administration, friends? Anyone? A few of y'all are aware, a few of y'all are not aware. Let me refresh this. I'm not able to click on this. Sorry, 1 second. Yeah. Popping up. Okay. So US Food and Drug Administration has the highest standards on the entire planet in terms of food. Whatever food that you consume, whatever medicine that you take, US FDA would approve that. If they approve, that means the food or the medicine that you are consuming is of good quality. That is what it means. Now, how many of you like chocolates? I request everyone to respond. How many of you like chocolate? Does not mean I'm going to supply chocolates to your home door. However, I'm just asking you. Okay, majority of your good. So here is your question. According to US, how many, let me write it here. How many insect fragments are permitted in 100 grams chocolate? Hey, what are you talking about? Insects? Oh my God. Why would they put insects? Sorry, 100 grams of chocolate. Why would they put insects in chocolate? They won't. All right, friends. So I think there was a slight glitch, but again, we fixed it. Glitch, you'll have to bear with it. Downtime, lockdown. Yeah. So those are the reasons. Okay. According to US Food and Drug Administration, how many insect fragments are permitted in 100 grams of chocolate? Anyone? Can you tell me? They won't purposefully add insects to chocolate. However, insects might fly into the chocolate manufacturing area and they might fall accidentally into chocolate. So how many fragments are permitted? I mean, if you have more than certain number of insect fragments in chocolate, they would reject that. But until certain number of fragments, it is safe. You can consume. Let us see how many of y'all will get it right. By the way, when I say insect fragment, I'm speaking about leg of a cockroach, head of a cockroach, head of a fly in that way, okay? And I'm sure after listening to this, none of y'all will say that you are vegetarians. Okay, 3, 4. Very funny, very interesting. Yeah. So let me go to US. I know you guys won't believe me, until unless I prove. Because you all are now data scientists, right? So you will say, hey, prove it with data, prove it with facts. So Food and Drug Administration and insects. Oh no, I need to type in FDA and insects. Here we go. Yeah, watch carefully, friends. Oh my God. Again, did you lose me? One second. But my audio is on. Hello. నేను రూమ్ వదిలేను
అలా పానిక్ బటన్ ఉంటుంది అది ఒక్కొక్కసారి reconnect to it అందరినీ ఇంకో దాంట్లో పెట్టేస్తారు immediately.
I think now issue is fixed. Guys, are you able to hear me? Okay, but you are able to hear me now, right? Let me see whether you are able to hear me or not. Okay. Yeah, there are certain glitches. I will ensure that tomorrow you don't face any such glitches. Okay, just bear with me for now. So here, if you all are able to see my screen, here is US FDA, and here you have this. Emitter 60 fragments per 100 grams of chocolate. Then what will happen? That would be rejected. I have another question for you all. How many of you all like orange juice? How many of you all like orange juice? Orange juice? Anyone? Again, audio problem? No? Okay. You all like? Okay. How many of you all like pulpy orange? Pulpy orange? Let me write it here by erasing it. I'm speaking about citrus juice, orange juice, etc.